Hello and welcome to your first hands-on Grasshopper tutorial called Points, Lines and Pipes. This is a video tutorial that you will be following along with and submitting as your first assignment, so feel free to pause and rewatch any section as many times as you need. Before we dive in, let me give you a quick overview of Module 1. You have 2 assignments and 1 quiz, and the first assignment, which we're calling M1.1, teaches you how to construct geometry entirely inside Grasshopper using points, lines, and pipes, as well as custom previews. At the end, we will bake the geometry into Rhino, which is how you move your Grasshopper output into the Rhino environment, and then we're going to organize it into layers and save it. The second assignment, which is M1.2, teaches you how to go the other direction, which is referencing geometry from Rhino into Grasshopper, and then we're going to craft the lofted bench surface by tracing profiles of a few of the famous chairs designed by architects. And then the quiz covers concepts from the lecture videos and the syllabus. Now let's get into it, and I want to start with something most people skip over, which is the origin of the name, because it actually tells you more about how Grasshopper works than any other introductory tutorial. In the last video, we talked about Rhino, where it came from, how it went from a niche NURBS modeler to one of the most important platforms in design. Now let's talk about what turned Rhino from a modeling tool into a computational design platform. Grasshopper was not always called Grasshopper. When David Rutan, a developer at Robert McNeil and Associate, which is the company behind Rhino, first released it in 2007 as a plugin for Rhino, he called it Explicit History. And that name is the key to understanding the whole platform. So let me show you what that means, and I want to show you the problem first. Say I draw these 3 interpolated curves using interpolate point command in Rhino. Then I'm going to loft it into a surface. Now I have a surface, right? But watch what happens when I try to edit one of the input curves. And you'll see that actually nothing happens to the surface. So the surface just sits there. So although we looked at commands such as list, which we understand that there's a history or a data log for each object such as surfaces or curves, but actually in this case Rhino does not know that the surface is exactly coming from the curve, or it knows but it actually is not responding to it. So your surface, your lofted surface, is not active. So therefore, although there's history, but that history is not active, right? It's not connected. So if I want to change the shape of this surface, then I either have to undo and then redo it, or I need to delete it and start over. Now, McNeil recognized this problem. In Rhino 4, they introduced a feature called record history. So let me turn that on and do the same lofting operation again using the same curves. Now watch happens if I edit one of the input curves. In this case, the lofted surface will also update. So that is a big improvement. So Rhino is now maintaining the relationship between the input curves and the output surface. But here's the limitation. Record history only tracks one operation at a time. It is fragile. If you do certain edits or transformation, the history breaks and the link is lost. So you cannot chain multiple operations together. You cannot also see the logic. So you can run commands such as cell object with history, which will allow you to highlight them. But again, with naked eye or just by looking at your file, it's not really evident, right? So it is definitely a step in the right direction, but it has its own limitation. And this limitation is why this concept of explicit history or Grasshopper was introduced. So I am showing you the same lofting operation, but right now we are conducting this lofting operation in Grasshopper. So you'll see that in this case, it's the same 3 curves, but now I reference them into Grasshopper and connect them to a loft component. We will learn about these names and these operations in the later time. For now, just focus on the logic. So in this case, the surface appears, but look at the difference. The entire history is not just recorded, it is also visible, and it's editable and it's live. So I can see the 3 curves. I can see the loft, I can see how they're connected. If I change one curve, the surface will also update. If I reorder the curves, the surface updates. If I swap the loft type, the surface will also update. And I can keep building on top of this. I can add more operations, more relationships, more parameters, etc. So the logic grows and everything stays connected. That is the leap from record history to explicit history. Record history remembers one link at a time, but explicit history, or Grasshopper, lets you design the entire chain of logic yourself. And one of the things that also made Grasshopper so successful is that it was never just one person's tool. David Rutan documented the entire development process on his blog, which he called I Eat Bugs for Breakfast. He also was instrumental in creating and advancing websites such as Grasshopper 3D, which became a place where designers, architects, and developers could follow along, share their issues, share their results, share plugin information, and it became this incredible way that up to today you can go there and look at over a decade of conversations about every single computational issue or every single plugin. Or another example of that is Food for Rhino website, which is an open platform where developers from all over the world publish plugins that extend what Grasshopper can do. So Ladybug and Honeybee are plugins for environmental simulations, or Kangaroo is a plugin for physics, Elk is a plugin for GIS data, Karamba is a plugin for structural analysis. So there are hundreds of them, and most of them are free. So when you learn Grasshopper, you're not just learning one tool, but you're actually plugging into an entire ecosystem of interconnected tools built by a global community of designers, engineers, and researchers. That is what makes it so powerful, and that is why it has lasted almost 20 years and is still growing. So the word explicit literally means precisely and clearly express, leaving nothing to implication. So here's a slide that I'm sharing with you where I collected some of the names or nicknames that people have used over the years to refer to Grasshopper. Some of these are maybe more comical than others, like spaghetti wire. Some of them hint at the look of the platform. But let's also look at the definitions here, which is definition of the word explicit. And we'll see that here in the fourth definition. It says that in mathematics, an explicit function has the form y equals f of x, where y is expressed directly in terms of x. So that's pretty much Grasshopper, where your input geometry is expressed directly in terms of your input parameter. So if you change x, y updates. That is the entire paradigm. So the most important thing I can teach you about Grasshopper has nothing to do with where the components are, but it is how to think before you place them. So this is what I mean by thinking explicitly. Before you start or get overwhelmed in Grasshopper, sketch an idea, try to describe it or write it out in steps, write those steps down, and then start to build it step by step. So that step, or this process where I'm asking you to describe or write out what you want to make, will result in something called pseudocode. Pseudocode, or fake code, is just plain language instructions written in order they need to happen. So this is a code where it is not something you can give to a computer or a program to execute. It is for you to understand what you need to do one step at a time. So think of it like a recipe, right? So before you cook, you write down the ingredients and the steps. You do not start chopping without knowing what you're making or how much you need to chop, right? So Grasshopper is the same. The pseudocode is your recipe, the components are your ingredients, and the canvas is your kitchen. So let me show you what we will be building together today. Think of it like the preview in a cooking show, right? The file that we create in Grasshopper is called a definition. You will hear me use that word a lot. A definition is not a 3D model. It is a visual script created in Grasshopper that has a set of instructions laid out on canvas as a network of components and connections. The definition describes how to generate geometry or any type of data. The geometry itself or data itself lives in Rhino viewport. So the definition is the recipe and the geometry is the dish. Today's definition is intentionally simple. 3 points along the z-axis, then create 2 lines And then we're going to pipe these two lines. We're going to assign two different colors to them. And then we're going to take this geometry out into Rhino. But the geometry is actually not the lesson, thinking behind is. And also it's really critical with this example to get familiar with the interface. So be patient and follow step by step. There's quite a lot of intricacy and shortcuts and information that's packed into this introductory tutorial. So also, I am going to give you instructions or our recipe for creating this definition, which is going to be our pseudocode. You will find our pseudocode on Canvas under assignment M1.1, written out before we touch the software. So here are the instructions. So every line here will become a group of components on Canvas. Every wire will be a relationship you are already defining in plain language. And notice something here in our third line. We're talking about a variable instead of a number, which here we're calling z. So in this case, z is not a fixed number, it is a variable, right? So the one decision, which is making the height of a point or z value of a point adjustable, instead of hard coding, will make us our first parametric model. So everything with this code will update as we update any of these parameters. So now let's start building from the very beginning.
Let's open Rhino, and first thing you see is the Start menu, that it asks you to create a new file as one of the options, where we could select one of its templates. So let's select small objects in inches. This sets your units, your grid spacing, as well as your precision. You can always change this by going to your command line, typing units, and decide if you want to continue in another unit type. For now, let's continue in small objects, inches, so I'm not going to change anything here. Then let's call a grasshopper. You can do that two ways. You can type grasshopper in the command line and then enter, or you can click this grasshopper icon on the toolbar. Either one works. So here it is. The first thing you see is this floating start menu, which references some help files that you can access later on. I'm going to X out of this. Then the other thing to notice is that Grasshopper is actually a floating window. It sits on top of Rhino, so you can maximize it, you can minimize it, or you can double click the title bar to shrink it down to just the toolbar. If you have two screens, I recommend putting Rhino on one and Grasshopper on the other. If you're on a single monitor, then keep Grasshopper on one side and then Rhino on the other, or tap between them. I'm going to keep it to one size and resize it so I can see both at the same time. Now, let's look at the title bar. Right now, it says unnamed. That means that we have not saved our project yet. So let's fix that right away. Before we build anything, we're going to save our file. To have access to save options, we need to go to File and create a new document. And we're going to use the naming convention that I'm showing you on the Canvas. So please review all the instructions on Canvas where I'm asking you to name the files using your first name, last name, underscore, tutorial, then M1.1. Then we're going to use the same convention for your Rhino as well. So you will notice that Grasshopper gives you two file type options. One is .gh, which is the standard Grasshopper binary file. It is smaller and faster. The other is .ghx, which is an XML-based format. It is human readable and usable for version control and for interoperability. But for this course, we will use .gh. So select .gh and save. While we're at it, let's also save the Rhino file. So go to Rhino, File, and Save or Save As, and we use the same name. So again, visit Canvas for all the instructions for naming. So let's get in the habit of saving both files with matching names. It makes your life easier, and it will also make my life easier when I'm doing your grading. So good. Now let's look at what we have in front of us. Below the title bar is the menu bar. Let me walk through each one quickly. So file is where you create, you open, you save, and you can also look at your properties. We will use this menu quite a lot. Under edit, we can undo, we can redo, copy, paste, and we can do, for instance, group operations. View controls how you see the canvas. And then display controls how your geometry previews in Rhino. So this could be the way that it's shaded or the way, for instance, your point is being displayed and a few other things. Solution controls whether your definition is actively solving or paused. If your definition gets heavy and slow, you can disable the solver and a few other options. Then we also have the help menu here, which it has your standard access points to continue with learning. So below the menu bar is the component toolbar. That is where all your tools live. They are organized into tabs, and each tab contains then subtabs or component groups, which McNeil calls them component panels. So we're going to use these terms, subtabs, component groups, and component panels interchangeably. Let me go through the main one. So params is for parameters and input objects. That is where you find, for instance, things like number sliders, panels, and anything that has to do with different type of data input or output. Maths is for mathematical operations such as addition or subtraction, as well as creating custom scripts in Python, C# or Visual Basics. Sets is for data management, for lists, trees. We're going to be working with these in our module 2. Vector is for point and vector operations. So for instance, today we're going to be working with a component from this tab. Curve is for creating and manipulating curves. So in this case, we're talking about different types of curves, and this tab is very similar to the way that operations are set up in your Rhino's curve menu. Surface is for surface operations, but also polysurface and solids. So we will use this in our M1.2 as well as module 2. So mesh is for mesh geometry. Then intersects is for intersection and Boolean operations between geometry, and this can be curve to surface, surface to or solid operations. Transform, it exactly matches how Rhino is set up. Transform is for moving, copying, etc. And display is for visualizing your geometry, for annotating and other things. And you might have also some additional other tabs. So for instance, kangaroo physics was recently added as a permanent component, and then there's a Rhino tab. But if you don't see anything beyond basically your display, that's completely fine. And as you start to add more plugins, you will see this tabs expand. To proceed, let's go back to our canvas, and we're going to look for the series of instructions which we're calling pseudocode, and this pseudocode is going to be used for us to create our definition. So go ahead and copy this, and let's go back to our Grasshopper environment, and we're going to use these instructions to construct our first Grasshopper definition. So under parameters, which is the first tab under input component group, let's look for a component called panel. And panels are one of the most useful components that we're going to be using. So under parameters, under input, hover over panel, and it says a panel for custom nodes and text values. So hover over, hold down your left mouse button, and drag and drop a panel anywhere on your canvas here. And what you'll see is that this is a floating component. This is a floating window, and it's asking us to double click to edit panel content. So if you double click, this is where I can certainly start to type, or if you press back, then right click and paste the notes that we just copied from Canvas and click out of the window. So you could drag your mouse to any of the edges and you'll see that you'll be able to expand this panel. And now we're able to see all the instructions, and it's okay if they're kind of going to second line. Now we're going to spend some time organizing these nodes, which we're going to call pseudocode, and that's going to guide us for constructing this tutorial. So first thing we're going to do is we're going to right click and we're going to click on this option called multi-line data. And what that does, it actually assigns an index next to each of the instructions, and that allows us to then basically organize the information as a number of steps. So I know that this is total of 9 different steps, so from 0 to 8, 9 different steps that I need to take. So why do we start from number 0? So this is convention in any computational counting that we start counting from 0. So our indices always start from 0. So this is something that we're going to spend a lot of time exploring as part of module 2. The next thing is I'm going to right click again, and I'm going to rename this. Instead of calling it a panel, I'm going to go ahead and customize this, and we're going to call this instructions and slash pseudocode. So basically, we talked about pseudocode as being text-based instructions for an algorithm or a series of operations that we want to execute. So think about this as your recipe, where we're calling it pseudocode. So it's a fake code, pseudocode. So if we give this to your computer, your Grasshopper, it's not going to execute, but it's good enough for me to understand and follow these steps, right? So this is our first experimentation with a Grasshopper component, which is in this case called a panel. Last thing is, let's also modify the look of the panel by right-clicking. We can go to the color option here, and you can adjust how your panel is being previewed. In this case, I'm going to turn this white. This is absolutely up to you, and you can adjust the color to whatever you see fit. We can also spend some time maybe adjusting fonts. I'm going to leave it as is, but all of these features could be adjusted. Okay, so we have our first component here. Now, this component doesn't really do anything other than providing instructions. Let's spend some time also looking at our canvas here. So our canvas doesn't have anything I can snap to. If I zoom in and out, you'll see that this is an infinite space that I can construct and place my components. I can use my middle mouse button to zoom in and out. I can hold down my right mouse button to pan around. And we're generally going to use it as a visual guide to organize information. Let's follow this first step, which is create point A at 0, 0, 0. If you recall when we were moving through these tabs, under vector tab, this is where we have our point subgroup. So these have a number of different components that allow us to work with different point operations. And the very first one, it says construct point, and it says construct a point from X, Y, and Z coordinates. So to use any of these components, when you hover over it, hold down your left mouse button and drag it on your canvas. And as soon as you do that, you're going to have a point preview on your canvas here. If I select my component, you'll see that that point turns green. And if I unselect it, you'll see that now that is set to red. So you might view a different preview for your component. For most part, you will be seeing something similar to this. If we go to our display menu, there's 2 options here. One is draw icons. If you check that, you'll see that the middle part of your component turns to an icon. So this icon matches the construct point icon. Then again, there's the second option that says draw full names. And once you check that, you'll see that it actually writes the entire name. I personally prefer working with draw icons and draw full names because I think it explicitly explains what you're looking at along the way. So I recommend for this tutorial to use the setup because it would help you understand what you're looking at. So in your component structure, whether it's a panel or whether it's a geometry component like this one, data always flows also from left to right, and that's how we're constructing our definition. Always data flows from left to right. And what that means is that it's receiving a value for X, a value for Y, a value for Z. And this value, if I hover over it, it says 0. And if I right click, if I go to set number, you'll see that that number by default is set to 0. So let's try to replace this. And let's turn that to 2 and then click on Command Changes. And you'll see that now my point, it moved forward 2 units. And now that value is hard-coded here. And I'm calling this 2 units because Grasshopper is unitless. Whatever units your Rhino is in this case we're in inches, then 2 means 2 inches. If my Rhino file was adjusted, so I'm going to go to units in my command line. And for instance, if from inches we go to meters or something else, 2 means 2 of whatever units your Rhino file is using. So that's the great thing about Grasshopper. It is borrowing your properties from Rhino, but it allows you to create light geometry. So here you could see that my point right now is moving forward. So just like we can use panels to write notes for ourselves, we can also use panels to preview geometry information. So for instance, the coordinates that it's outputting. So if you recall, we went to parameters under input to grab a panel, or if you know what a component is called, such as panel, you can double left click anywhere on canvas and start to look for that name. So if I look for panel, then that's a panel and I'm able to retrieve it. Same thing with my construct point. If I double click and type construct point, enter, you'll get another construct point. So this one is the adjusted one, and this one is the original one, which goes all the way to 0, 0, 0. So this is a way for us to be able to, once we know what we're looking for, recall components. So at any point when you're looking at multiple components on your canvas, we could So any of these components that you are using at any point, you can select and delete them. So in this case, I'm deleting the second one that I created. And we could also double click again and look for them. Now, it is really critical for us to know exactly the name of the component we're looking for. So for instance, if I forget that this component is called construct point instead, if I type point, you'll see that I get many different options. And if I enter, you'll see that I have a component that's very different. So in this case, this is very different than construct point. This is a point container, which is nested on the parameters under geometry point. And all the components under these parameters geometry, these are not a way for us to input coordinates, but these are a way for us to either reference geometry from Rhino or migrate geometry from one part of Grasshopper definition to other. I also want you to pay attention to the color of this component. So our construct point currently is this light gray color. So it takes input and it provides output, but this component is orange. So let's look at this diagram where it talks about 3 different colors that you're going to come across. So the light gray is for components that have enough information for them to do something, and that something could be construct a geometry or create a specific data type. Orange components are components that are still waiting or missing information. So in this case, for the point component, it's waiting for a point to be referenced. Then there's the third option, which is components that are red. And red usually is not good news. And what that means is that it either does not have the right type of geometry or data, or we're doing something wrong with the way that geometry is or that data is structured. So in that case, whether we're working with orange components or red components, there's some troubleshooting that's involved. So let's go back to our canvas. And I want to right now also take advantage of this panel that I have here, hovering here. If I take my construct point component and I'm going to connect the output of my construct point to the input of the panel. So if I hover over the output grip, so these are called grips, hover over here and hold down your left mouse button and connect, you'll see that the same panel that earlier we used to basically attach or add our pseudocode right now could be used to read information, right? So right now it's telling me what the coordinates are. Let's try to do the same thing for this component, although it's I'm telling you that it's still missing information, but let's see for ourselves. So I'm going to grab another panel, or if you double click on canvas, and because panels are something that we're going to use all the time, let me show you a shortcut, which is just entering quotation mark, enter. So that gives you an empty panel. So I don't need to type a panel. You just double click and quotation mark, and that will give you a panel. So now let's connect the output of our point container here, and you'll see that it's telling me that no data was collected. Well, because this is missing information. So if you right click and go to runtime warnings, it says floating parameter point failed to collect data. Or if you hover over it, it says empty point parameter. So all of that means that it is still waiting for information. Great. So one other thing I want to do before we proceed, anytime that you have a component on Canvas, it doesn't really matter what type of component, and you want to know where it comes from. Maybe you forgot, maybe you're looking at a definition that has complex components. I'm going to show you a very, very useful shortcut, which is if you hold down Control Alt together. So press Control and Alt, and then using your left mouse button, click right in the middle of the component, and it draws these diagram of where to locate that. Again, Control Alt, so press together, and then left click on the component, and it tells me where to find it. Same thing with the panel, right? So very, very useful. Again, Control Alt together, press together, and then left click right in the middle of the component. Great. So now that we have this, let's clean up our canvas a little bit. I'm going to delete this panel and the point container. We're not going to need it for now. And then let's go back closer to what we initially wanted to do, which was creating a point at 0, 0, 0. So if you recall, we overwrote the x value. So let's right click on x again, go to set number, and this time let's remove this completely and then tell it to commit changes. So I'm not adding a value, I'm removing it, commit changes. You'll see that now my component also turned orange. So any component, again, if it doesn't have all the ingredients, so right now it has Y, it has Z, but missing X. So it turned orange. Let's right click on it again. Let's go to set number. And for the last time, I'm going to change this to 0, commit changes, and there it is. So that is our point A. So next thing I want to do is to also create an annotation. So then I know that this is created as point A. If we go back to our canvas, you'll see that here I'm asking you to group and label sections of your canvas as point A, point B, etc. So that's what we're going to be doing. So earlier, we saw that if we go under Edit, there's an option to group. And grouping is a way to not only organize your content, but also it allows us to add annotation and text to what we have. So anytime you have more than one component, so here and here, let's say I'm going to misalign them and then select them together, you'll see that you have this alignment tool. So I can tell it to align to top, or I can tell it to align to center, right? So it's really up to you how you want to organize things. So I'm going to select these together, and we're going to go to edit and then click on this option that says group, or you'll see that the option is Control G. Now, when you do the grouping for the first time, your color is going to look We're going to select them and we will go to edit and then select this option that says group or Control G. And as soon as you do that, you have a boundary box that's created around your two components. And you can see that if you move your component, that boundary is expanding. If you right click right on the box, you'll see that there's an option here to name, and we're going to call this our point A. So that's how we can name our groups. Then there's option to do different types of grouping. So the blob option and this rectangle outline, it allows you to also separate and splits the name. For this tutorial, that will take up too much space, and I think you would need to be a little bit more advanced to be able to manage your components that way. So my recommendation is let's go with the box outline. Great. The next thing is that pay attention to the color. So basically the color of your group is something that you could reset. So I recommend pick a different color for this group. We're going to start to change the coloring, whatever that might be. Great. And then click on this option that says make color default, because by doing that, next time we group, you're going to follow the same grouping color. And that will help us to keep the next 3 points the same. Otherwise, we have to go back, and then when we're doing color, you want to match the RGB. But by setting it as a default color, then you don't have to worry about that. It really doesn't matter what color your grouping is, as long as we're going to keep the points the same color, lines a different color, etc. Great, so we have our point 1. We're going to proceed to create our point B. So it says for my point B, it is 0, 0, and a Z value. So pretty much I'm going to follow the same structure, and then we're just going to adjust the value for Z. So since I already have the same thing constructed, I can then hover over this, and we're going to do Control C, Control V. So we're going to copy paste and move this down. And first thing, we're going to right click on the box, and we're going to call this point B so we don't get it confused. So the problem is that right now point A and point B are overlapping, but what we need to do is to set up this thing called a variable Z. So we need to make this in a way that we can adjust it quickly. So earlier we saw how we could right click and adjust the number, but in this case, if every time you're clicking and adjusting, that is going to be a little bit tedious. So we're going to look for another input type, which we're going to find under parameters, under input, which is called a number slider, So drag number slider on your canvas by holding down your left mouse button and dragging your number slider here. And you'll see that your number slider looks a little bit different than the other two components we've seen so far. The other two components have an input grip and an output grip. This one only has an output grip because it only provides input. So what is a number slider? Let's connect our number slider to the Z value. So hover over the output and connect it to the input. And you'll see that now my values are also adjusting. So my point B is parametric, and I can just adjust the slider and I'm able to then change the value. So this is a quick way for us to then look for different options. Let's just imagine we're creating a floor to ceiling height variable and you're able to adjust this. Now, by default, when you're creating a number slider, if you hover over it, you'll see that it gives you basically a range between 0 and 1, because 0 and 1 work for a lot of different operations, especially if they're parameterized, meaning they're remapped to be between 0 and 1. But for instance, in this case, it might not work because let's say I want this to be up to maybe 12 inches, right? So basically, it's going to be critical for us to be able to adjust this. So if you right click, you'll see that one of the first things we have is to adjust the name. And let's rename this as point B Z value. Actually, let's call it variable. So that's point B's Z variable, right? So you can either keep them generic or you could rename them. So right click again, then let's go down to this option that says edit. And you'll see that here, there's option for us to, for instance, change the type of slider we're making. So by default, this has 3-point decimals floating point. But if I change it to integer type, and I'm going to press OK, it can only go from 0 to 1, right? So there is no in between. Right click again, go back to edit. I can turn it back to floating. Let's keep at 3 decimals, but I can change the maximum. So for instance, if you double click on the maximum, let's take this up to 10 and then click on this green option to commit changes and OK again. Now my range is expanding, right? Right click again. Under edit, you'll see that there's a lot of different options. So for instance, even to have even numbers. So click on E, and what that means is I'm going to just jump to only even numbers. Right click again. The type could also be modified maybe a little bit faster by having these shortcuts. So if I flip this to odd numbers, now I'm only snapping to the odd numbers, right? Right click again. If you hover over and go to values, you'll see that the minimum and maximum is also something I can adjust. So first I'm going to adjust the type back to floating and hover over, go to values again. And instead of 1 to 11, I'm going to double click and let's change this to be 20 and then commit changes again. So this is just a variable for us that change, and the sliders have a really flexible way for us to work with this. Now, if sometimes you're in a hurry, you're not sure what the number is, you can even start to drag these by scrolling and dragging these numbers up and down, you can adjust them, right? So for instance, I could go up and down this way. Your minimum could also be a negative value. So for instance, I can make this a -10. So it could go from -10 to 110. Right now, we're just exploring these. So you could see that it goes from a negative number to a positive number. And there's that. So let's finalize this number once and for all. Right click, go back to edit. Let's look at the large window, and I'm going to switch this back to 0. And then I'm going to set up my maximum to be 20. And we're going to lock it at that and press OK. Great. So similar to the way we work with our canvas to call a construct point component or a panel component, I can also do the same for our sliders. So if you double click and look for a slider, you'll see that it actually has some other options like an MD slider. It gives you a two-dimensional slider, and that's not what I'm looking for. Double click again and type slider, and you can see that you have to be quite specific calling it a number slider. Okay, that works, but as I told you, there are some components that you're going to be using quite often, like a panel and a slider. So let me show you a shortcut for accessing sliders, but also customizing their values. So I'm going to delete this, and I'm going to actually move you down here. So we're going to spend some time just creating some random sliders. So similar to the shortcut that we had for a panel, if you double click on canvas and this time enter a number, and this could be any number, let's say 5, and you'll see that automatically it converts it into a number slider. So go ahead and enter. So if a value is between 0 and 10, it gives you a slider between 0 and 10. If you enter integer, it will give you an integer slider. Now the same thing, if I give it a floating point, it will give me a floating slider. So let's try to scale this up. I'm going to enter a number between 0 to 100, 25. That's the range it'll give me. And then the same thing, if I now create decimal values, it will give me still the same range, but with that specific decimal value. And this is exponentially growing. So if the value is between 0 to 100 or between 100 and 1,000, and that's going to be the case. So 125, or let's say 320 with however many decimal values I want, right? So this is a great way for you to quickly create sliders. But sometimes you want to be very specific because maybe your geometry is heavy or you don't want to waste time trying different numbers. So I'm going to select and delete these. And I will show you a shortcut where you're able to set up the start and end of your slider. So for instance, I want a slider that starts on number 1 and ends on number 20. So 1 less than 20, enter, and that's what I'm getting. So from 1 to 20. And the same thing, let's say 1 less than 20, but if I make any of the numbers, either as a start to end based on floating points that I want, that's what I'll get. So that number could be anything. Now, if I want to get more specific, so for instance, I want to have a start, like let's say 1 less than, I want my gripper to be on 5, but I want it to end on 20, that's what I'll get. So you have a start and where your slider gripper is, and then an end. And as you can imagine, it's the same thing based on decimal values and whatever that might be. So this is a really useful shortcut for us to then customize sliders. So from this point on, when we're creating slider, I said, let's create a slider, double click, enter from start number, less than where the gripper is, less than an end value. And then if there's any decimal values, I'll tell you, and then enter, and we have it. Great. So we're not going to need any of this. So let's select and delete, and let's go back to our point B. So currently I have my point A and then I have my point B. Now what I want to do is I want to also include this slider with the group. So select the item that you want to add to a group, right click on the boundary of the group and tell it to add to group. And there it is. So we have our point A and point B, and I'm going to move them a little bit inside so we're kind of on the right side of the line. Great. So the next thing is we're saying let's create point C, and now it's 0, 0, but then whatever X is, which is this value plus number 4. Okay, so let's go ahead and create another copy of this point that we have. I'm going to click on my point A again, Control C, Control V, move it down, and we're going to first rename it to point C. And then we're going to say whatever this value is plus 4. So to do an addition, we're going to go to our maths. And under operators, we're going to look for an addition component, drag and drop on canvas. So we're going to say whatever that number is. So let's provide that number as our A input. And then the second number has to be 4. So I can certainly right click and enter that number. I can provide it as a slider, but let's say in this case, I want to make sure that that's a fixed number. So similar to the way that we can use panels to provide, let's say, instruction text or read what our component is doing, we can also use it for input. So we're going to double click again. We're going to use quotation mark, but this time we're going to enter a number, which is 4. So if you provide the exact number that you want, that's going to be what's in our panel. So now I have a panel with value 4, and I'm going to connect that, and that's going to be that number plus 4. So let's provide another panel. This time I don't need an input inside. We're just going to use it as a preview. So double click, quotation mark, enter. And I'm going to then provide the result of the addition. So you'll see that now when I move my slider, whatever that number is, plus 4 equals that. So now I can provide that as the Z input. And you're going to spend always some time organizing your canvas. So whatever makes sense for you. So that becomes the Z input. There you go. So now as I'm moving my slider, so that's a variable, but we always have a fixed distance. So let's say that's floor to ceiling, but then thickness of the floor above is fixed, right? So whatever that might be. Okay, fantastic. So let's go ahead and also select these 3 components we have. We're going to right click and add it to the group. So now I have my point A, I have my point B, and I have my point C. So let's just spend some time aligning these. And it's absolutely your preference how you want to organize this. I'm going to just move this a little bit over, and then maybe I'll align it this way. And as I mentioned, you could select components and you can start align also the spacing. So I'm going to align that, and I'm going to align this. Great. So your definition is auto saving, so don't worry about saving that. But if you ever need to do that, just do File, Save, or Control S, and same thing with your Rhino. Okay, fantastic. The next thing is for us to draw a line between point A and B, and then between B and C. So lines are type of curve. So we're going to go to our curve tab, and under primitive, we're going to look for a line component. Drag and drop that here. And you'll see that now this is orange. We know that orange means it's waiting for information, which is the start point and end point. And it shows us the preview. So I can either connect directly from the point output or from the panel. So let's try both options. So from the panel, you can connect one and then the second one. And as soon as it has information, it's changing. So there's the line. Or I can, right now I'm not disconnecting. I'm going to directly just hover over the point output and connect this. And you'll see that it automatically replaces the wire, right? And the reason for that is that by default, Grasshopper can only take one input at a time. So whichever one is the latest, it's replacing the information with that. Now, if you ever want to actually disconnect this, it doesn't matter which one is connected, hold, I'm going to zoom in so you can see this better. I'm going to hold Control, and if you hover over an input or an output, you have this red arrow with a minus sign. So then you can draw back, right? So I'm going to do this again, Control from one end to the other. So it disconnects the wire. You can connect again. Then the other option is if you right click, there's an option to disconnect. And if you hover over that, it highlights the wire. It's basically asking you, do you want to disconnect? I'm going to say yes. And we can also disconnect it this way. For this tutorial, I recommend we connect directly from the point because actually these panels are additional previews. And in a sense, like if you decide later on you want to remove the panels, you can also go ahead and do that. So I'm going to do it this way so then you could see the wire going there. And then now that is my line 1. So let's select and we're going to do Control G. We're going to group it to itself, right click, call that line, do it this way, line 1. And I'm going to right click to actually change the color of the group. And I'm going to click on make color default. So then this way, next time I create a group, it has this blue color. So then my points are one color, my lines are one color. So let's also repeat the same operation between point B and C. So if I double click and look for a line, just keep in mind that this first option is again a container. So that's under parameters line, per geometry line. But this is line that allows us to create a line between 2 points. I'm going to delete this. And let's try this one more time. So line. So start to get used to the icons, or you can always just navigate and go through the menu and basically read what the operation is, right? So that's the line component that we need. So this time I'm going to connect from point B to point C. And there it is. Great. So let's also group this, Control G, and we're going to call that line 2. Okay, so let's look at our pseudocode. We have line 1, line 2. Now I'm going to create pipe 1 and pipe 2. So pipe is a type of surface that we're creating. So let's go to our surface tab, and you can see already the piping icon here. That's why the icons are great. So go under freeform and look for pipe. And for piping, it's looking for a curve, and this could be a line type of a curve or a different type of a curve. And then connect the output of the line to the curve input. And you'll see that even though I only connected one parameter, it is turning gray because it actually has everything else that it needs as a default, as a preset. So it's using this radius of 1 as a default. So it changed color. So let's create a slider for the radius. I'm gonna open up a little bit of space here. I'm gonna double click. Let's make a radius that goes from 0.5 less than 2 less than 5, 0.5 less than 2 less than 5. And we're gonna connect that to the radius. So you see that now I'm able to connect or complete the radius using a slider. And I'm gonna move this a little bit over, and I'm gonna right click on the slider, and I'm gonna rename this. We're gonna call this pipe 1 radius. Then if you look at the pipe, it's basically an open pipe, and here we have different way to cap it. It says 0 is no capping, 1 is flat capping, and 2 is round. If you right click, you'll see that it actually has these options explicitly, so I can select flat or round, or I can also control this with a number. So when it gives you these options, if anytime that you have to right click and go inside a component, it's, for instance, I don't know what that is unless I hover over it. The idea is to make everything explicit. So if it says 0, 1, and 2, will give us these options. So let's make a slider that goes from 0 less than 1, less than 2. Then now I connect that to cap, and I'm able to just go between these options. So let's right click on the slider, and let's call that pipe 1 cap type. Right? And we're not going to worry about fit rail because this is a very simple curve, so we actually wouldn't see any difference. So let's leave it as is. We're going to group this to itself. Control G. We're going to right click and call that pipe 1. And let's also change the color to something else. So we're starting to, it will be easier for us, like on Canvas, to distinguish operations based on color. Great. So we need to now basically repeat that for that, but let's look at the pseudocode. It says pipe for line 2 or pipe 2 is pipe 1 and whatever the pipe 1 radius is times 2. So it means that whatever that radius is times 2. So we can grab the component first. So let's double click and type pipe, enter. Then what we need to connect is our line 2. And this is right now inheriting the default, and we're saying the radius is whatever that is times 2, which means I don't need my own slider. I just need to do an operation. So we're going to go to maths under operators, grab a multiplication, and we're going to say whatever that value is. So provide that as input 1 and times 2. So we're going to treat this similar to what we did here, right? So we're going to make that a fixed number when we did the addition. So we're going to say whatever that is times 2. So I'm going to double click on Canvas, quotation mark 2, enter. So that's going to be our multiplier. And I want to also see the output. So double click another quotation mark panel. And let's look at the output. And this is just for me to verify that this is working. And then, so whatever that number is times 2. So if I adjust it, this should also change. Now that becomes my radius, right? So whatever that is times 2. So right now we have two parametric relationship. One is between point B and C, then it's the radius. Okay, great. So then it is our cap. For now, I'm going to just use the same capping option. So I'm going to first remove the slider from this group so we can use it as kind of a joint value. So select, right click, and remove from group. So that's a way where you can remove anything. So same operation as adding, but then you're removing. So select the object, right click, and you can add or remove. Then the next thing, I'm going to right click on the slider and call this pipe 1 and pipe 2. So we know that this is linking both. Then I'm going to take this output, connect it to cap, right? So right now it's controlling both of the caps. Then we have some grouping and renaming to do. First, I'm going to select my pipe 2. I'm going to separate the slider. I'll do Control G, but see if I forgot to set that up as a default color, my color is inherited from here. So I'm going to do Control Z. I'm going to right click again on this color, go to make color default, select again Control G. Now it's matching the color. I'm going to right click and call that pipe 2. And that's it, pipe 1, pipe 2. And I'm gonna just group this to itself and leave it as is. But as long as they're the same color, it's easy to keep them the same. Okay, let's spend some time talking about the colors that we're seeing on the screen and the fact that we're seeing every geometry here. So at this point, we already know that if I select something, it will turn green. But why is everything represented with this red color? So if we look at these series of icons on the upper right corner of Grasshopper, these allow us to manipulate different preview options. So for instance, if we look at this circle here with 2 colors, if you left click, it brings up this preview document preview settings, which will see that this is where all the default colors are set up. So by default, every geometry is this red color with 100% transparency, right? You see that I can change that. And then everything that's selected is this green color. Now, if you are colorblind or if you have other preference, feel free to adjust these colors. You can either drag one of these colors over or adjust it here. I'm going to leave it alone just so like it matches preview of most of you going forward, but this is something you could do. Then if we come over here, you'll see that there's this thing called Draw Shader Preview Geometry. So if I switch between these, you'll see that it takes the shaded preview and it's giving me wireframe. And then it's turning off preview at all. So if I go back to my display tab, display menu in Grasshopper, you'll see that this is where these previews are set up, from preview setting for document to shaded view, and there's the shortcut. So Control 1 is no preview at all, Control 2 is a wireframe, and then Control 3. And for the most part, you should be fine by if you want to show the shaded preview, but sometimes in the future, we'll see that our Grasshopper will get heavy. So that's when we would switch to a wireframe preview or no preview at all. And that just makes your computation lighter. The other thing is that right now we're seeing everything from the points that we've constructed to the lines and to the surfaces. So certainly at this point, we're not looking at anything complex, and we can definitely make up what is what. But depending on your preference or complexity of what you're looking at, anything that we select, so for instance, if I'm looking at this point here, point A, you can right click and you can click on this preview option, which is a toggle. And if I turn off the preview, you see that the color of the component also changes, right? So right click, preview on, right click, preview off. Also, you could hold down your mouse and hover over any component, and you'll see that not only there's the preview icon, but there's a number of other ones such as grouping. And again, this one, you could turn the preview on and off. And these cloud preview options or cloud components are also applicable to more than one things. So if I want to turn, let's say, number of points on or off, I could do that using that kind of cloud shortcut menu that we have here. So right now my points are off. Or at any point, one really useful shortcut, and you can use it for one or multiple, if you select and press Control Q, and that is like a Boolean where you can see that if I'm holding Control and Q, I'm turning the preview on and off. So same with, I can do that for multiple. So here, one is off, one is on, and I'm able to switch between these options. Now, the critical thing is to just pay attention to the color. So if I'm just generally looking at this, these are darkers, it means it doesn't have a preview. And these are lighter, it means there's a preview. Sometimes preview could be geometry, and sometimes that's not a geometry. So in this case, it's an addition, multiplication. There's some exceptions here, and we'll get to them as we go forward. But let's say if I do not want to see these lines, I can select one or multiple and use Control Q, or let's say here, I can use my middle mouse. Same thing with the pipes, right? So we can turn the preview on and off. So one good practice is that you turn them off as you go forward. So right now we're at a point where we have pipe 1 and pipe 2. Okay, so the next step for us is to assign custom colors to pipe 1 and 2, and let's see what that means. So earlier when we were going through the tabs, we say that we have a tab called Display, and this is where we could go under Preview, and there are these components such as Custom Preview that would allow us to visualize our information with unique colors or materials. So let's go under Display, under Preview, and hold down your left mouse button and drag one, and you see that this component is very different from what we've seen so far. So far, we've seen components that have inputs and outputs, or only outputs, but this one only takes inputs. And it looks like the end is cut off because it actually just provides a preview. So there are a number of components, especially under this tab, that only provide preview. So what is a preview and how is it different than, let's say, material properties or rendering materials that we have in Rhino? So since we are creating a preview inside Rhino, basically we have the capability for us to take geometry such as this pipe, and let's connect the pipe to the geometry input. And you see that this component, it basically takes the wireframe and the transparent to something that has more materiality. So it has colors, it has specular. Now, this has a default material input. Keep in mind that color and material are different properties. Later on, we'll look at how to make custom materials and how to take this material into Rhino. For today's tutorial, we're only going to look at a color replacement for this material, which we're going to find under parameters, under input, and we're going to use a component called color swatch. So drag a color swatch on canvas here, and you'll see that now I can use a color swatch, which actually looks like a number slider, right? Because we actually grabbed it from the same place, and connect that there, and I can right click and I could customize that with something that I like. So I don't have a specific requirement for the color. Just select the color that you like for your component. And I'm going to quickly visit our canvas here, and you'll see that here, I'm just asking you to name things, and we're going to name this custom preview. And that's the name of the component, which is custom preview. So let's go ahead and select these two together, Control G. And I'm going to right click and call that custom preview. And I'm going to call it custom preview 1. Then right click and change the color. So as long as it's different, maybe I can go more green. Then maybe I can give it some transparency. Totally up to you what you want this colors to be. So there's that. Now let's go ahead and make a copy of this entire group. Select over it, Control C, Control V. And I'm going to just replace the geometry input. And you notice that here it says geometry. It's not telling me surface or curve. So this custom preview could apply to any type of geometry. And there it is. And I'm going to just change that color to something else. And we're going to right click again and call that preview 2. Okay, perfect. So we have everything right now and it looks fine. If I were to use any transparency here, so I'm lowering the alpha channel, what will happen is I would also see the preview of the pipe underneath. So if I don't want to see that, I'll just select right click, turn off preview, or Control Q, and now I could see that a little bit better. Same thing for this. Let's right click or Control Q and turn off the preview. And you can decide whether you want to keep it transparent or not. Now, keep in mind, this preview option is still not super sophisticated. So because these are basically overlapping, we see that discrepancy here, but there's better ways of doing this, which we'll cover in next tutorials. But please, for now, go ahead and adjust the colors as you see fit. And let's again quickly look at our canvas so you can quickly tell the ones that are darker that don't have preview versus the ones that do have preview, right? So because Grasshopper is a visual algorithmic editor, it is set up in a way that you could quickly take a look at it and understand how your algorithm is flowing. Okay, so what we are left to do is this last step. It says bake pipe 1 and 2 to Rhino on labeled layers. So let's first talk about what baking is. So as you know, up to this point, what I'm creating is a preview. Now, when we are creating geometry at any point, either it's an input or output, I can right click on a component that has geometry, whether it's a curve, whether it's a surface. Let's click on geometry, right click, and you'll see that there's an option to bake. So if you recall the whole conversation we had about explicit history, the fact that we're basically preserving history of the geometry, if we are baking a geometry out of Grasshopper, it means that we're freezing it in time, right? So basically, when we bake geometry, then if I adjust variables here, then it is not going to be restored. So it's a little bit like that option where we were looking at where we're lofting once and then you freeze the geometry. So I want you to take a moment, come back and look at your variables and adjust it to maybe a setting you like. Maybe I'm going to make this an exact number. And if you want this to be an exact number, you could either try to stop at, I don't know, let's say precisely 13, or you could double click and enter the number and enter. So that's one way where you could actually lock the geometry or lock the number down. And we're going to keep that at 4 because that's fixed. But then let's come to the radius. And let's also make the radius, let's say 1.5, double click, make this 1.5 and enter. So that's one way where you can assure that you don't have any weird decimals. We're going to keep that at 2. And then for capping, I'm going to try to bake this with this rounded cap. Now, feel free to adjust this number to whatever you like. I'm keeping you on this. I'm showing you these numbers because I wanted to show you how to stay on a specific number. And now let's say this is a setup that you like. And I'm going to now bake this first geometry, which is this pipe 1. And before I do that, I'm going to go to my Rhino, and it has given me these default layers. And I'm going to right click on one of the layers, and I'm going to rename that to pipe 1. And I'm going to go to the second layer, and I'm going to call that pipe 2. And I'm going to activate pipe 1. And let's go back and recall Grasshopper. So if you ever X out of your Grasshopper, and if you're not seeing your Rhino environment or your geometry disappearing, don't worry about it. Grasshopper is not, you didn't lose your work. Just click on the icon again and it will come back, or you can just call it from your command line, or you can minimize it, or as I showed earlier, you can just double click on your taskbar and you can minimize and maximize. So in this case, I have 2 layers that I've created and I want to bake the geometry to those layers. So right click on the geometry input or geometry output. Either one of these would give us the same result because basically we're feeding the same geometry, then we're applying color, right? So I'm going to do it from here because it will be easier for you to see. Right click, click on bake. And what baking does, Grasshopper is accessing your Rhino layers. So click on pipe 1 and then go ahead and press OK. So as soon as you do that, you'll see that your geometry now is in Rhino and you could, adjust it, preview it. So if I X out of my Grasshopper, that's the only thing I'll be seeing, right? Because there's nothing else, there's no preview. So bring up Grasshopper again. And we're going to repeat the same step for our pipe 2. So right click, go to bake, and then click on pipe 2. And then we're going to press OK. So later on, we're going to look at more of these settings. For now, just leave it as is. Click on pipe 2 and press OK. So now there it is. So these layers currently are basically referenced in Rhino. So if I turn them on and off, you'll have it. My recommendation is now select these two together, hover over it, and then using your gumball. If you don't have your gumball on, make sure that it's activated. And then just select your X value and just drag it to a side. It really doesn't have to be a specific number, but I want you to just separate it so then when we call grasshopper again, you could see the difference between them. So last step, what we'll do is we will clean up our Rhino layers a little bit more. So right now we have pipe 1, we have pipe 2, but all of these other layers that Rhino gives you by default are empty. So let's go to your command line and use a command called purge. And it gives you different things if you want to purge or keep, have those all checked and press OK. And what's great is that it will get rid of everything and it will just give you these two options. So this is where we will stop for this tutorial. So please go ahead and save your Grasshopper file and your Rhino file. So make sure that you save them and then upload both the Grasshopper file and Rhino file as part of your submission for this assignment. Make sure that you name them according to the convention that I've given you on Canvas. And I hope you enjoyed this tutorial. And this is the fundamental tutorial that we're going to build on going forward. Thank you for your attention.